We are the Percussion Pants Project. My name is David Gonison.
My name is Eddie Goins.
And my name is Heather Reisinga, and we will present to you the drum pants.
Alright, so here we have the physical makeup of the drum pants. As you can see, this is the FSR. There's 4 of them, just like this. It's about 1/2 inch by 1/2 inch sensor pad. When you hit it, it changes the resistance of the pad, which makes a change in voltage at the input of the microcontroller, and that is sent to the Bluetooth and then to the phone to make the sound. And here we have a belt on the pants. And inside the belt there's a pocket on the inside there. That's where the microcontroller and Bluetooth set, with all these wires that come out and run into the pants. Right next to it is the 9-volt battery. On it is a switch that turns it off and on. So you do not have to have the drum pants constantly on. Right now I'm connected here, so we can give just a little bit of a show how it works. And those are the sensors on the little pants legs. And that is the physical makeup. It is unobtrusive, discreet, and quite comfortable.
We designed our PCB from the Bluetooth microcontroller and voltage regulator blocks. We were able to put all this into a compact 1.5 by 1 inch form factor PCB. We were able to do this partially by using 0402 surface mount parts. These parts are approximately 1 millimeter by 0.5 millimeters, and we also were using 3.3 volts from the voltage block in a form of a 3.3 voltage regulator. This voltage is perfect for power efficiency, and plus the Bluetooth runs on 3.3 volts. So we are able to make it power efficient, last all day. And the main design challenges of this block was we took the LilyPad Arduino board and used that for reference, so we knew how to make a compact, power efficient board. And we're using the 328P, which allows for 2.7 to 5.5 volts, which allows the 3.3 volt to work perfectly. And the sensor blocks, or the sensors, were connected to the sensor circuits, which just consist of resistors and voltage dividers, and then those are fed into analog converters on the microcontroller, which convert the analog signal from the sensors to digital signal that can be read by the microcontroller, that we then use to see how hard someone's hitting one of the drum sensors. Then we send that information over the microcontroller to the Bluetooth app. And that's the main purpose of the microcontroller PCB.
So here we have the block diagram. There is the power supply, which is a 9-volt battery, which has its voltage regulated down to 3.3 volts, which powers the pants sensors, the microcontroller, and the Bluetooth transmitter. The pants sensors also get input from the user in the form of striking the sensors with their hands, which produces a voltage pulse that the microcontroller detects. The microcontroller is controlled by the microcontroller code block, which tells it to send the sensor data to the Bluetooth module, which gets transmitted wirelessly to the Android device, and the Android code block figures out which sensor was struck and plays a sound based on that. The Android code block also gets input from the user based on what they press on the GUI, which chooses sounds and sensors and connecting to Bluetooth. Around all of this is the enclosure, which is made up of the pants and the belt.
For the audible drum sounds requirement, we used a decibel meter to make sure the sound is above 60 decibels. To test the all-day use requirement, we looked at the constant use for the drum pants for 2 hours straight. For the removable requirement, this is satisfied by making the circuitry removable in less than 1 minute. For the consistency drum requirement, the user sits and stands multiple times. If the sensor plays more than 10% of the time, this test fails. For the durability after being worn requirement, We test by wearing the pants all day and then seeing that they still worked afterwards. The walking durability test requirement. We walk with the pants for 1 hour and then test for functionality afterwards. For the discrete requirement, we have less than 20% of the surface area of the circuitry and components showing. For the low cost requirement, we used less than $300, which is our budget. The minimum audio lag requirement, we verified that our drum sounds had less than 250 milliseconds between hitting the drum sensor and sound playing. For the multiple drum sensors requirement, we have 4 functioning drum sensors. For the multiple sound effects requirement, the Android app allows us to choose whichever sound we want to use. For the power switch requirement, we have an on-off switch. The selectable sounds requirement, the Android app allows sounds to be chosen. For the slacket joints requirement, we have at least 2 inches of extra wire at each joint for easy movement. For the washable requirement, the circuitry enclosure is intact after washing.
So this is the project demonstration of the drum pants. First we're going to turn on the device, a little switch here on a 9-volt battery that goes to the microcontroller, and that delivers the power for all the drum circuit. And next we're going to have the app connect to Bluetooth. App wants to turn on Bluetooth. Yes, it's turning Bluetooth on for you. And we'll select which one. Wait. And it's connected. So, then we're going to test out the sound. Good, it's all working. And now you're ready to drum. It's that simple. And that's the demonstration of the drum pants.
My part of the project was to make this Android application. This application will let you select your sounds and connect to the microcontroller, and it will be the speaker for playing the drum sounds. All the important stuff happens here. So you can select from the different sensors. So on the top there it shows sensors 1 through 4, and then you can just select it and it brings up this file browser where you can go back and go to different folders. So if I choose this file, it's a symbol. You can replay it as many times as you want. Just make sure it's really what you want. And then you can, the phone will actually remember what you chose, so if you back out of it and get back in, if you load up, if you select sensor 1 again, on the top it tells you that it's the same, that's the file name, and it's still the symbol sound, so if you press this button, it'll play the sound for sensor 1. There's also a volume slider, makes it quieter. Can't hear it. This is a percentage of your actual volume, so if you have your volume turned down, you're not going to be able to hear it. It'll also remember the volume settings, so I put it down this far, and if I back out, get back in, it loads it back up, and it remembers the volume level. At the bottom are buttons to test out the different sounds that you have. Just before you even get a chance to connect to the microcontroller. And then, of course, there's the button to connect to Bluetooth. It will load up your previously paired devices, and if the device you want to connect to, the microcontroller, is not on the list, you can select Scan for Devices, and it'll start to scan. It's not currently on. There's nothing currently on right now that hasn't already been paired, but you have that option. You can do it from within the app.
Thank you for watching our presentation. This project has been a very unique experience for all of us, and we've enjoyed it very much. I hope the drum pants will be able to entertain all those involved.